Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, or good morning, everyone. I would like to thank you for the chance for our team so that we can participate in the 6th International Conference on Science and Technology 2020. I will introduce myself. My name is Nastiti Utami and our team is Reni Banuwati, and our supervisor there is Professor Nuryono and Professor Bambang Rusdiarso. Welcome to our presentation that has talked about recovery of iron 3 from gold mining rock with silica chitosan coat on iron sand magnetic material. And then I will present it with the outline. First, introduction, objective, method, our result, summary, and the last is acknowledgement. And there is our photos when we got sampling in the Kokap Kulon Progo with our supervisor. There is Professor Nuryono. So into our introduction. Our research background is based on the Mineral Commodity Summaries 2017, saying that gold mining in Indonesia from 2015 to 2016 increased from 97 to 100 tons. But distribution of gold in most geological sample is not homogeneous. The abundance of gold occurs in alloy of gold, silver, copper, and associated with other minerals like carbonate and sulfide minerals. There are several methods to obtain gold from aqueous solution, such as solvent extraction, precipitation, adsorption, and the method to obtain the gold that has been widely used, amalgamation and using mercury and cyanide method. There's we know the effect to the health of the human. So we choose the alternative method. They are more environmental friendly. There is adsorption. Adsorption of gold in rock or electronic waste solution has been done by using active carbon. So we choose organic hybrid material has potential to use as an adsorbent. There is iron sand magnetic material coated with silica chitosan. Silica gel can be used as an anorganic matrix in our adsorbent because it has high mechanical and thermal stability. Then the silica gel surface can be chemically modified through covalent bonds with organic compounds. Chitosan is an aminopolysaccharide. This compound has an amino group and the hydroxyl group. And the last is the magnetic has paramagnetic properties. So we can easily to separate solution from adsorbent. Our objective, the work includes preparation and characterization of adsorbent, and then gold leaching from the rock sample, and the last is adsorption desorption of Au3 in leaching solution and calculation of recovery. The method, the first synthesis of our adsorbent. There is the mixture was the synthesis process to get mole ratio of magnetic silica chitosan. There is 1:1. The mixture was stirred with addition of hydrochloric acid 1 molar to reach the pH of 10, and then ammonia hydroxide 0.5 molar was added into the mixture to get the pH of 7. The result gel was left overnight, then washed and dried at 60 degrees Celsius for 24 hours. And the second, the solution of a rock sample, gold mining rock sample, was crushed and sieved to 200 mass, then roast at 650 degrees Celsius for 1 hour, and then the sample was added aqua regia and heated at 70 degrees Celsius for 4 hours. The filter was added with 0.1 molar sodium hydroxide to reach pH to 3, and then the sample solution was added with the buffer solution of potassium hydroxide phthalate in 0.0 molar hydrochloric acid. And the third, we applicate a recovery of AO3 from rock sample solution. There is a 20 milligram adsorbent was added to 10 milliliter of rock sample solution. The mixture was shaken for 1 hour at room temperature. And then add adsorbent that have been separated, that was washed and dry at 60 degrees Celsius for 2 hours. The adsorbate metal ions were eluted with 6% solution of thiourea for 1 hour at room temperature. So we enter to our result. There is characteristic of adsorbent with infrared spectrophotometer. Based on the obtained FTIR spectra, the wide characteristic absorption band at 3433 overlaps stretching vibration hydroxide and amino. And then in the 570, we can see like stretching vibration, ferry, and atom oxygen. And the second is our characterization with the XRD. The result is a shift occurred to large angle in the characteristic peaks of magnetic, since the spacing between the planes was getting smaller, indicating the coating process with silica that success. There is in the spectra in C point, we can see still have characteristic of magnetic. So the magnetic or chitosan is not damaged with the mixture, in the mixture. And we go to the theme characterization. We can see the coating of silica around the magnetic. There is magnetic. Made size of magnetic more larger than before coating. And after coating with silica, there was clear slit around magnetic particle, indicating a silica, while dark area in the composition was a magnetic material. Specimen analysis with EDX mapping was carried to show distribution of element in our adsorbent. Based on mapping result, there is elemental nitrogen, oxygen, iron, silica can be distributed evenly. And the second analysis of the metal gold, copper, and zinc in the leaching solution was performed with stereo addition method by AAS. The content of our room 3 was smallest it was around 0.01% in the sample solution. The method to purify gold can be used is selective adsorption. Adsorption with the material that has active site of amino group in our adsorbent. There's the picture is our sample in the rope, and then after that we cross or grinding and the sieve to 200 mass. And the next, the recovery of aurum tea from rock sample solution. There is the most species of AU3 can adsorb with adsorbent in the because the adsorbent has positive charge, causing the condition with below the 0.0 charge of chitosan. Chitosan in adsorbent MMSC containing amino groups and can be protonate to form the cation of alkyl ammonium. So the metal ion aurum 3 can absorb to our adsorbent. There's the picture. The color change of adsorbent after process of adsorption occur from the yellow to reddish brown. The color change indicated the absorption and the reduction of AU3 to aurum 0. And then the last we can separate it with external magnetic, then our adsorbent that was absorbed many iron metal. We can use the thiourea was selected as an eluent to desorb aurum 3. Based on selectivity and stability, desorption was conducted in the closed vessel at room temperature. Aurum 3 was not stable in the solution of thiourea, so that it more likely to oxidize thiourea, and it was reduced to get aurum 1. The formed complex compound was affected with the polarizability of the central atom and ligand, which can be explained with the hard-soft acid-base principle. There is the reaction with thiourea with the aurum 1. Okay, so the solution of thiourea with aurum 1 classified in soft acid forms the stable complex compound. Aurum has low electronegativity and large size, so that aurum has high polarizability. The metal ion with high polarizability, like Cu and zinc, it interact strongly to form complex with the soft bed. According to HSAB principle, Cupri2 and zinc2 are classified in borderline acid. Those ions have the lower affinity against soft base than aurum. So we can see the value of the D was the higher value than the AU, the values distribution of the aurum was the higher value than the cupri and zinc. Okay, our summary, there is the content of AU, Cu, and zinc in the gold mining rock sample with aqua regia was 0.14, then 16 and 118 milligram per gram. And then our absorbent